The action potential allows us to sprint down fields, figure out complex math problems, and brew our favorite teas. It all starts when a neuron is stimulated. Neurons make up our nervous system and are responsible for transporting information throughout our bodies. When a large enough stimulus acts on a neuron, either from our sensory organs or another neuron firing, an action potential is triggered. An electrical impulse runs along the neuron's body to send information to other neurons or our muscles. How is it possible for electricity to be generated in our bodies, though? Well, a neuron starts with an electrical potential of negative 70 millivolts, meaning there's a difference in charge between the outside and inside of the cell. Inside of the neuron, we'll find lots of potassium ions, negatively charged proteins, and some sodium ions. Outside of the neuron, there are mostly sodium and some potassium ions. When a stimulus triggers the neuron, the voltage inside increases slightly to about negative 55 millivolts. This causes voltage-gated sodium channels located on the neuron cell membrane to open. These channels allow the movement of specific ions between them and open only at certain voltages. In this case, sodium starts to flow naturally into the neuron. This movement of sodium gives the cell a positive charge. At plus 30 millivolts, the sodium channels close, the potassium voltage-gated channels open, and potassium ions rush out, making the cell negatively charged once again. At negative 70 millivolts, the potassium channels close and the cell is back at its resting state. This process is what is responsible for the electrical impulse sent through the neuron. These electrical impulses can happen in quick succession, up to about 200 per second. Neurons fire at different frequencies based on the information they're relaying. If you're in danger, your neurons are firing much quicker than if you were laying on the couch. The action potential is a fundamental process that in turn helps us realize our own potentials.